Welcome to our new unit on measurement and stoichiometry. We're going to start this unit by taking a look at scientific notation. When scientists take measurements, oftentimes numbers get very, very large. For example, measuring the distance from Earth to the nearest star, well, it's this many kilometers. That's a really big number. Sometimes in science, numbers get very, very small. For example, when we look at the hydrogen atom and we want to know its radius in millimeters, well, it's this number. It's a very, very small number. Sometimes it's not very convenient to read a number like this, 0.000000106 millimeters. So we have a different way that in science we write numbers like this. We can create a much more meaningful representation by using scientific notation. Any number can be written in scientific notation, regardless of the number. And we write the number basically as the product of two numbers, the product of a number between 1 and 10 and a power of 10. That means we're going to multiply one number that is between 1 and 10 by a number that is a power of 10, 10 to the something power. Here's an example. Here's this very large number, okay? It can be written as, instead of 39,900,000,000,000, we can write it as 3.99 times 10 to the 13th. So how do we do this? How do we figure out how to do this? Let's take our very large number, okay? And we write the very first factor as a number between 1 and 10. So we take this large number and we move the decimal point to a place that creates a number that is between 1 and 10. That number would be 3.9. Actually, 3.99. I didn't write that other 9 there. How many times would you multiply this number by 10 to achieve your number? We would multiply it by 10 13 times. And then we can write that as our exponent of 10. So we can say 3.99 times 10 to the 13th. That means we're going to multiply by 10 13 times. If we do that, we get this number. This is just a much easier way to think about it and to write it. So now you try one. Write this number, 460,000, in scientific notation. If you answered 4.6 times 10 to the 5th, you were correct. Now what about small numbers? We said small numbers also can be written this way. Let's look at our example, okay, our atomic radius. We can use the exact same rules. First, we write the very first factor as a number between 1 and 10. So where can we move this decimal point to create a number between 1 and 10? We can move it right there, 1.06. Now, how many times would you divide this number by 10 to achieve your number? So here, note that we will be moving our decimal to the left. We're going to be dividing by a power of 10. So our exponent is going to be negative. We're not multiplying, we're dividing. So we write 1.06 times 10 to the negative 7. You try writing the following numbers in scientific notation. Remember, when you move the decimal right, the exponent is positive. When you move the decimal left, the exponent is negative. So you try these examples, and I'll give you the answers on the next frame. Here are our answers. Recall, 4.2 times 10 to the negative 4. That means if we move this decimal place to the left, because it's a negative 4, we're going to move it to the left 1, 2, 3, 4, and that gives us this number. What about this number, 5,200? Well, 5.2 would be our first factor, times 10 to the third, because when we take the decimal point and we multiply by 10 3 times, we get this number. Same thing here and same thing here. Okay, now that you know all about scientific notation, it's important that you know how to add, subtract, multiply, and divide using scientific notation. Let's start with multiplying. Let's say I have two numbers, 2.1 times 10 to the 4th. And I want to multiply that by 1.0 times 10 to the 3rd. You know the order of operations does not matter when you're multiplying, so we can make this easy for ourselves, and we can take these two terms, multiply those together first. 2.1 times 1.0 is 2.1. Now, let's multiply the exponential terms, the 10 to the 4th times the 10 to the 3rd. How do we do that? We add the exponents, 10 to the 4 plus 3. So my answer to this problem would be 2.1 times 10 to the 7th. Very nice. Now let's look next at dividing. So when I divide, make that a little bit thinner here. When I divide, let's look at some similar numbers. 2.1 times 10 to the 4th divided by 1.0 times 10 to the 3rd. How do I do that? Well, let's look at these terms first. 2.1 divided by 1.0 is just 2.1. Now if I look at these exponential terms, 10 to the 4th divided by 10 to the 3, well, when I do that, I subtract the exponents, 10 to the 4 minus 3. I start with the exponent on the numerator and subtract the denominator. If this had been a negative 3 here, 10 to the negative 3, I would take 10 to the 4 minus a negative 3. So you want to make sure you keep track of the sign on those exponents. So my answer here is just 2.1 times 10 to the 1st, or 21. Okay, now let's add and subtract. How do we do that? Well, if I add and subtract, if I have a number like 2.1 times 10 to the 3rd, and I want to add another number, and let's say that number doesn't have the same exponential term, it's 1.0 times 10 squared. I actually can't just add the 2.1 and the 1 and say times 10 to the something convenient, because when I add and subtract, I must have the exponents in like terms in order to do that. And you can just prove this to yourself if you want to by adding them manually. You know that 2.1 times 10 to the 3rd is 21,000. And that added to this, because these exponents are in different terms, this is 100. They're not in the same terms. So you're really getting 2,200 for your answer. So this is a very simple problem, and it does not matter in this problem. But if you had more difficult, complex numbers, you may want to put these both into the same exponential terms. And that's not hard. You can just say 21 times 10 squared to change the exponential term there. And then you can say 1.0 times 10 squared. Now they're both in the same terms of 10 squared. And you can add them together. I can say 21 plus 1 is 22. And then I can say times 10 squared. They're both in the same exponents. 22 times 10 squared is 2,200. Check my answer, I'm getting the same answer. And that's how I do that. So when you add and subtract exponents, or with scientific notation, the exponents have to be in the same term in order to add in that manner. So do a few of these practice problems on your own, and I look forward to seeing you in class.